let's do the next script. The most important part for today. This is the most important thing to learn, filters in Earth Engine. Okay? Stop typing. Let's learn the next bit, script 3a on filtering data. One way to start your coding is through a code snippet that you find in the catalog. You can also search for dataset here. So if you search for a dataset name in the search box, it'll actually give you the dataset right there. So you can search for places, but also the dataset. So you can see I have found this data. This is the data I want, and I can just click import here. So you'll just import the data in here. When you import it, it'll be assigned into a variable called image collection. So right now in my script, I have a variable called image collection, which refers to the Sentinel-2 collection. Let me just change this. I can click on this part. It's editable. I can make it S2. So now I've renamed this variable. So I have a variable called S2, which is referring to this collection. When I started working with Earth Engine, I was very, very scared at this point, right? In remote sensing, you are used to working with few images that you load in your software. This S2 variable contains all Sentinel-2 images ever collected everywhere in the world. Few million images, hundreds of terabytes of data. And now you have this in a variable, and I was afraid to even touch this, right? What if I break something, right? So in Earth Engine, the paradigm is different. In traditional remote sensing, you start with some data that your professor or colleague downloaded, and you start with that. Here you start with everything, and then you filter it down to the data you need. It's unlikely that you're probably working with every dataset ever collected. Right? You want dataset for some time range for your region that meeting some criteria. Right? So almost all Earth Engine code will start with filters. So we'll learn about filters. And this is where we'll start working with the API and learn how the API functions are. So filters allow you to select a subset of data. Let's learn about different kind of filter. The first one is a date filter. You are able to filter the data using a date range that you want. Let's define a new variable. So you have the S2, and there's a function called filter. So let me show you that function. Whenever you need to learn about a function or what the function can do, you can switch to this docs tab here. And we are running this function on this object called image collection. So I'll look under e.imageCollection. This will tell you all the functions you can run on an image collection. Okay. I'm going to browse here, and I'll find this function called filter. When I click on it, it goes to documentation. It says apply a filter to this collection. So there's this function called filter, small case filter, where you can apply a filter. You can see the input to this function is something called a filter. So it says, give me a filter, and I'll apply it. So this function says, I want some filter, and I'll apply that filter to it. Okay? And this one is a capital filter. We'll learn about this. So let's say I want to filter this. So I'll say s2.filter. This will say, run the function filter on my S2 image collection. What's the input to this? Well, it needs some filter. So I'll just say, I'll create my date filter. How do you create a filter? Well, Earth Engine comes with a whole range of functions to get you to create different filters. And those are available under ee.filter. So go and switch to the docs tab on your computer, find the ee.filter, and find me a filter that I can use to select images collected in year 2019. I want to select those. Go and find a function that we can use to apply this. Okay, this is the number one skill that I want to teach you today, how to read the documentation and find the function that you need for your thing. So when you find a filter, raise your hands and call it out. Which filter would you use? Yes. E-filter date, right? So there is a function here, e-filter date. There are a lot of similar looking functions. So you need to click on it, read the documentation of what that filter does. So this is filter a collection by a date range. Okay? There is a start and end parameter. It says start, the start date, end date. So you give a date, 2 dates, it'll filter this between this thing. Important thing to remember, the end date in this filter is exclusive. So the last date is not included. So if you say filter it to Jan 1st to 31st December, 31st December is not included. So in Earth Engine, you always filter it to one more day. So if you want 2019 images, you'll say 1st Jan 2019, 1st Jan 2020. Okay? Let's run this filter. How do you create this filter? It says you run this function ee filter date, start and end, and this will return a filter that you can use, a capital filter. Okay? So I'll say I want to run this here, ee filter date, and I can say 2019-01-01, and end date is 2020-01. Okay, so this line has created my filter, and I can say I have a filter. I can use this to filter this in my filter function. Yeah, go ahead.
Maybe a silly question, but it's how does Google structure dates? Month and day and month?
Yeah, it's an ISO standard. So year, month, date, not American standard. So.
And another one, sorry. Can you put a date that it's obviously in the future?
Yeah. It'll just say, if you say 2025, it'll work, but then there's no images there. But if you are working with the climate prediction data, there is data for up to 2021, and you can do this. And you can also go in the past as much as you want. Okay. So what this will do is, the filter variable now contains all images everywhere in the world collected in 2019. Okay, we just apply this. Everything is case sensitive. This filter is small case. It needs a filter where you create using this e.F function. Most of the time, people don't do this. Like you first create a filter and use it. You just say, I can just directly create this, right? You can just say, you can just do this. Right? I'll say dot filter, and I'll just create the filter right there. So I don't have to create a variable and save it. So you'll see mostly code written like this, where you say s2.filter, e filter date, and this is the date. So now we have this filter variable containing all images in the year. So let's apply one more filter. I don't want all images in 2019. I want images in 2019 collected over some region. First, we need to define the region. So I'm going to go to the city of Bangalore again and say I want all images collected over this. You can upload a shapefile of the region that you want. You can use that as an input. You can also just drop a point. Earth Engine has this thing here. These are the drawing tools. So if you just want to define a geometry right here, I can use this drawing tools here. There's a point, line, polygon. I can just take this point and just click and drop here. And you'll see your code now has a new import. There's something called geometry at the top. It says you just dropped a point and you got a new variable called geometry, which is this point here. So now we have a location. So now we want to apply a location filter where you want to say find all images that are intersecting this point. Okay? Go and find me a filter that I can use. So I'm going to define a variable. I'll take the previous collection. So I take my filter data, and I want to apply one more filter. What filter would I use? Go look under the e.filter module and see which one I can use. Yes. Bounds. Yes, there's a e-filter bounds function is there, which says I take two parameters. When you see the parameters, the stuff in italics is optional. Okay? So you might see a lot of functions where there are many variables, but this one is optional. So if you don't give an error margin, it'll just say, I'll use whatever, optional. You can skip that. So the only thing you need is geometry. We all have a geometry. So we can now just run this function. We can say e-filter bounds geometry. Done. So my filter2 variable has all images collected over this point in 2019. Okay, so now I've narrowed down my search to a smaller region. One more thing we can apply is a metadata filter. Maybe I don't want all images. I want images meeting certain criteria. I'll define it as all images having cloud cover less than 30%. When ESA processes these images, they add a metadata, what is the overall cloud cover in this image. So you say, I don't want to work with very cloud images. I'll select only images which have less than 30% cloud cover. Let's look at the dataset description page. All the metadata is here, image properties. there's one property here, cloudy pixel percentage, which tells you what is the percentage of cloud cover in that particular image. So I want to now say I want to select all images having this value less than 30, right? That's my metadata. Let's write code for this. I have filtered 3. So I'll take the previous variable, filter 2, apply one more filter, go and find me a filter that allow me to select this. Let people find it. I know you found the answer. Yes? So your question is, you would use update mask?
I would create a mask and then...
Yeah, so update mask will is a different kind of filtering. So here you are saying, I will remove all scenes where there are more than 30% clouds. Masking says, I will keep the scenes, but I'll just remove the pixels which are cloudy. That's called cloud masking. So that you can do, but right now we're just saying, let's not work with any scenes that are overall more than 30% cloudy. Yeah, anybody found the filter? Yes. NEQ, there's an E filter, NEQ, so not equal to will not work here. We want to have filters that less than 30% cloud cover. LT, so there's a filter called E filter LT. Let's look at that. Filter to metadata less than the given value. Okay, so it says two values, the name of the metadata and the value that you want to use. There are some other functions you might have found. There is a very nice looking function called eFilter metadata, right? And you say, oh, this is great, I just want this. It says, deprecate it, do not use. Right? So, okay, it says use the eFilter LT and so on. Right? So, let's use this, we'll say eFilter LT. This is the name of the property, cloudy pixel percentage, 30. We have the filtered. You can print the result, filter 3. If you've done everything right, it should show us how many images are there over this region collected in 2019 having less than 30% cloud cover. You can see I've got some output. You can expand this. There's features. So if you expand this, this shows me the 30 images that matched my filter. So we started with millions of images and we filtered down to the 30 images that are collected in 2019 over the city. If you look at the IDs of the images, you can see this one all have IDs like 2019, 1st Jan, 4th Jan, 9th Jan, and so on, right? So it's all 2019. If I expand this, each image has the property. And I can see this one, cloudy pixel percentage 0. So it's a correct one. And I can go and look at other images. This one is 0.5% cloud cover. So again, good to also check your code that you got it. So you can say this one is a 28% cloud cover. And we got it because we had this filter. You can change the filter and your images will get. So we got 30 images that were collected over this region which match the criteria. There's a helper function. If you just want to say, I want to know how many images match this, you can run this function called .size. So I say print filter 3. Instead of printing the whole collection, I can say print filter .size. Just give me the number. So there are 30 images that match. Helpful when doing the research. It's like, okay, do I use 30% or 20%? I really want very less clouds. If I do 10%, oh, there are 21 images, less than 10% cloud cover. Right? So you can kind of see the result immediately. Questions on filtering? So this, go ahead.
Hello. I would like to ask regarding the filter bounds. If we had a polygon instead of a point, and how would that work if we had different tiles of imagery?
Let's do this. So I can delete this geometry and let me draw a polygon. So I can draw a polygon, sorry. I can draw a polygon. So I've drawn a polygon and I run this. You get a different answer, right? What this did is all images whose footprints intersected this polygon. That's what we got. Okay? When you point, it just say all images whose footprint intersected that point. Here you have all the footprints that intersected. And the Sentinel-2 scenes are 100 kilometers by 100 kilometers. So since the polygon is quite big, there might be like multiple scenes. That's why you got large number of images matching that.
Another question?
Yeah, go ahead.
Just sort of a follow-up question. I assume that one of these filters would allow you to not just get images that intersect that polygon, but that completely include that polygon.
Yeah, so there's a E filter within.
Okay.
So you can say, give me all where the geometry is within this particular polygon. So that is available. But mostly, those are little advanced filters. Most of the times, you just say filter to all images intersect, and then we'll clip it. We'll say, I want to remove all pixels that are outside my region. So I don't care about I just find all images, and then I can clean it up later on. Yeah.
And maybe just to add on that question, like, okay, Sentinel also works in a similar way where there are predetermined orbits, right? And so, for instance, if you were using Landsat or if you're using Sentinel and you know the specific orbit that you're looking for, because maybe there's a specific part of Bangalore that he's looking for, etc. You could also put that in the filter and say, only give me the ones that fit this specific orbit that you know the names for. For instance, it's very common with the Sentinel-1, the SAR data, that there's a specific orbit that's also defined if it's ascending or descending, how it collects. And so then that way too, you could then make sure you don't get images that say are overlapping in a way you don't want to.
So almost every Earth Engine scripts needs to start with a filter. And this kind of syntax is a bit error prone, right? You say filter, then filter 1, filter 2, like you take the previous one. It's very easy to make a mistake. What if I just made a mistake and say, I just forgot 2 here. Now I have completely wrong code, right? I have used the wrong variable to use the filter. So since you apply this filter one by one, Earth Engine provides you with a helper syntax using something called chaining. So let's see how this chaining works. You can start your filters like this and say I have a filter, but instead of ending my command here, I'll say I'll continue my command. I'll say I have applied one filter, take the result, apply the second filter. So I'll continue my code. So I have one filter. I'll take the next filter and say, apply this. So this says, take the S2, apply this. Whatever is the result of that, apply one more filter. So the dot is the chaining operator. That means you can do multiple commands in sequence. And we can keep chaining as much as we want. So we can say, I want to now take this and put this here. And I have my filter. And once I'm done, I can then put a semicolon. So now my filtered variable has all of these filters applied on the data. And if I print the result, same. Right? The answer is the same, but this is much more friendly syntax, which is less error prone, and everybody uses that. But I wanted to show you that this is what's happening internally, but you can chain this. And chaining is available for all Earth Engine functions. If you want to run one function, next function, you can just put dot and continue doing your data. Yes?
Well, you just answered my question. I was going to say, if functions also going to be the same. So if you put the workflow, so you basically go the steps with the dot.
Yeah. Typically, like what you do is you do this, and then you say map a cloud masking function, map a function for NDVI. You just keep doing, running functions on the same data, one after the other. Let's do the exercise. Exercise 3C. We have the code that takes the S2 data, applies this filter, and finds the images that you want. Here I want you to delete the geometry. So here, come here and delete that. So first step is that you can just go and delete this. Go to your city or area of interest, wherever you want. So maybe you want to go to San Francisco, and drop a point wherever you want those images. And then I have a filter you need to do. Change the filter here to find images from September 2023. So I want you to find how many images are less than 30% cloud cover collected over your city in September 2023. So go and try to work on this exercise. First step would be this to delete the geometry. So come here, delete it, and you can drop a point there. We have 45 more minutes before lunch break. If people want a quick bio break, feel free to just go. And yeah, you need help. I think it's a multi-point. Just delete it first. Did you put multiple points?
Yeah.
Okay, it's fine. It'll find images that intersect all of those.
So
And
how do I delete that?
yeah, just delete. There's a delete button here. Yeah. And now drop another point wherever you want.
Okay, so
And your restart helped with your Wi-Fi? How did you get the Wi-Fi? Okay,
Yes.
cool. That's yeah.
So like a couple of months ago, I already got your tutorial. So I have to update it.
Yeah, this is different. Yeah, so don't use this one. You have today's one.
So no, yeah, it's here.
Yeah, not this one. Yeah, so go to that link, the bit.ly link that we had. So this one is a slightly different, it's a condensed version of that. So we need a new repository. Yeah, let it just load. Thanks. Just refresh it. Yeah, now go at the bottom. Yeah, now you have it. So this one is the GE introduction. And you need to do this one, yeah, 3C. Okay. You can see September 2023, the filter will look like this. The end date will be 1st October, not 30th September. Because the end date in Earth Engine filters are not inclusive. So if you do 30th September images are not included. So make sure it's always one day more. Did anybody get 0 images? Yeah. If you do this for Bangalore, you'll get 0 images. It's a rainy season in Bangalore, and you have no images with, no cloud cover. So it's totally fine.
I changed mine to 30 because I thought it was because
Yeah.
of the cloud cover to 10. I hadn't put an end date in because I just wanted it to be. Is that?
Yeah. So if you don't do end date, it'll say all images collected between the start date and 1 millisecond after start date. So, yeah. If you got 0 images, change your cloudy pixel percentage filter. Maybe just remove that filter, or may say I will tolerate more clouds. There's a way we'll deal with the problem of no cloud-free images soon, but that happens with a lot of regions. This is one of the limitations of optical data.
When, for example, I would like to change this one.
0, 1 dash.
Yes.
0, 1.
0, 1. But
Quote,
it
single.
it delete the color.
Oh, you have insert, yeah. Insert is on, that's why.
You press
Insert button was on.
insert button.
Yeah. So now you can do, I think it will work.
Okay.
Yeah, I think it's there. Yeah.
I got geometric error. I delete jaws. And I add new one.
Yeah.
Oh yeah.
Right, time's up. Let's move on. And again, if you didn't finish this or got this, it's okay. You'll see the solution in the next part, and it builds on each other. Every script is independent, so not to worry.